Like you're in my brain.
I am.
Like I'm just thinking thoughts, but in your voice.
There you are. You are.
There I am.
I have to just adjust the
Oh, now,
window. What?
hi. Oh yeah, you got.
I got to do all
Now
these
really
fancy
annoy you.
things.
Now you'll go over here. Can you catch me over here?
Yeah. Where's
Oh
more
man,
comfortable for you? I know. You're
this is good. This is my nook.
okay. We'll make that your nook. Do you want to tell everybody who you are while I'm setting this all up? Because you know that's what we usually do.
That's right. We got set up, and I'm Dr. Paul Sutter. I'm an astrophysicist at Ohio State, and I'm here to answer all. That's right, all of your questions about any topic you want. I'm here for you for 1 hour. Clock starts now.
Clock starts now. Can everybody hear him? Okay. Um, what is this high quality? I know we've ditched Zoom. I'm done with Zoom.
Isn't this great? Isn't this great? Feels good.
It feels really good. I'm so over Zoom.
Turns out I've been high def this whole time.
I know. It turns out there's probably not going to be those chirps and those artifacts, and it'll be amazing.
I hope not.
So
Or maybe I just make chirps.
maybe.
It's a part of my speech pattern.
So how was first and foremost? You just came back, well, 2 weeks ago actually, from a 3. Has it been 3?
It was a while ago. Time means nothing to me.
That's not something you're supposed to say as in the field you're in. Time.
Well, no, I'm above time and space. I look at it like this, and so it's nothing. It's insignificant to me.
So he guys he does these astrotours.com or no .co, right?
.co.
.co.
.co. Or I prefer this URL, astro.tours.
That's really fancy.
Astro.tours.
That's super fancy. I don't know if I can
That's
handle
nice.
that. So you did
I think
this.
you can.
So what did you do? So tell people about Astro Tours and what that is.
Astro Tours is a science travel company. So where we take groups of people who love science, we put them somewhere amazing, and we put with them one of their favorite science communicators. So it's a way for fans to connect to the celebrities in their world, for the celebrities to connect to their audiences, talk about science somewhere cool, do something cool together. So we've done one trip to Iceland to go aurora hunting. And a few weeks ago, we just did a Caribbean cruise to do sky watching off the deck of the ship, which was amazing every night. We went to see Mayan ruins and learn about how the Mayans incorporated astronomy into their world. And this coming December, we're going to the Atacama Desert of northern Chile for a sky watching retreat. We're actually booking. Can I do a plug?
Of
For an
course,
upcoming
please
trip?
do. Please.
Yes, we are booking right now a trip to Costa Rica to do sky watching, to check out volcanoes and jungles and coffee plantations and so much cool stuff. It's a really, really fun trip. So if you're married to someone who isn't into all this astronomy stuff, it's cool. These trips have tons of stuff that isn't just astronomy related. So spouses have a great time, even if they're not astronomy nerds like you are.
Right. So they can like zip line and, like.
Oh yeah, no, that's part of the Costa Rica trip is ziplining.
Of
And there's a
course.
link. Thank you.
Yeah.
/Costa Rica. We're booking for that right now. That one's led by myself and the wonderful Fraser Kane, publisher of Universe Today. We have a trip being led by Pamela Gay. Next year, we have a trip being led by Ethan Siegel. Next year, and I'm putting the finishing touches on an invite email for someone.
No names dropped.
No names dropped, to someone to join us for an all-stars party in Joshua Tree National Park in California in June.
That would be amazing. Whoever that person is, I bet they're going to be so excited.
Bet they're going to be really excited about the contract negotiations that will ensue.
Oh yeah.
Oh yeah.
Oh yeah.
Lots of back and forth. But I bet they'll be excited to turn around and tell their fans and their audiences that we can all party together in the desert. It's like Burning Man, except we stay in a nice resort and we have lots of water. We only go in the desert at night.
So no baby white baths.
No baby white baths, no dust orgies or whatever happens there. Nothing is gonna go on fire, especially telescopes. Those things are very expensive. Those
Do not. It's
very
not
far.
burning telescope. No burning telescope.
We're not doing burning scope. And we're just gonna look at the stars and we're gonna have a really great time. There might be ice cream.
There might be ice cream and maybe cheese.
There might be ice cream. Well, okay. Cheese is during the day.
And beer.
There will be some cocktail receptions. But we're working with the hotel, or actually emailing with the resort right now of how can we get ice cream to the desert.
Great.
That's our we're working down the list.
Right.
We're working down the list.
We got to start somewhere, and these are priorities, right? So
yes. So hopefully by the end of the week, someone, a few people, because it's gonna be an all-stars party.
Right.
A few people are getting invites.
Yeah, Joe's like, so I'm thanks so much, Paul. Joe just thanked you.
Yeah. So Joe, I didn't want to say it. But Joe, would you be willing to take your audiences and fans to a long weekend trip in Joshua Tree National Park?
And we'll just wait like 12 seconds for his response.
For him. Sure, I guess.
Am I finally gonna no vulgar? No. Let's see. Is this an invite only, or can you? No. So you guys can buy tickets. That's the whole point of this.
Yes. So the all stars, the people leading it, those are gonna be invitees. Some relatively famous people, but yeah, it's open to the public. You buy a ticket. It'll be on the website. Same place where you can go and buy a ticket to the Costa Rica trip right now.
Mm-hmm.
You'll be able to buy a ticket to this.
Yeah. So these are, and I'll link that again. I'll put that also in the description of this. And then when I export it to YouTube as well, it'll be in there. So you guys have the links to these things if you guys are ever interested in ziplining and seeing stars.
Yeah. And for everyone who signs up because of this, like right now, I will personally pay Skylias $50.
That's amazing.
Boom.
And then I have to give that to Joe.
Yes, of course. It's so great. Like I own the company, so I can do whatever I want.
Right.
And so I can just decide unilaterally that if anyone books any Astro Tour, so we have a few going live right now that you can book into, but we're really pushing the Costa Rica because we want to sell that one out. If you book into that because you saw it here, I will contribute to Skylias.
And so is there a way that they can let you know that they booked it from here?
Yeah, so the travel agent for the company is a wonderful woman named my mom.
I love my mom.
Yeah, she's employee number one. She does work for the company Astro Tours, and she handles all like the reservations and the airline ticketing and all that stuff. Mm-hmm. And as part of the conversation, she finds out, how did you hear about it? And if they say heard about it from Skylias, that'll go in the database. And then at the end of the trip, I go through the database and I pay out all the referrals.
Sweet. That's amazing.
There it is.
Will my mom bring homemade cookies on the trip?
My wife does, because she's a baker.
Yeah. And maybe I could too, if for Joe's trip.
I'm not going to tell you to not bring cookies on Joe's trip.
Right.
That's for sure.
Mm-hmm.
And
Speaker says, wait, this is a good question. How are you not 300 pounds? Your love of cheese, and then your wife makes cookies.
Struggle is real, folks. I actually just for Ohio State, we get like $50 off of our health insurance premium if we do a screening every year where they take your blood cholesterol and they weigh you and everything. And I ate so much food this past weekend. Like an unbelievable amount of food. My wife and I, we went to visit some friends of ours in Princeton, and they're from Italy. And so when we visit them, they just cook nonstop.
Right.
And just assault us with food. And like Sunday night, they made 8 pizzas. Eight,
Eight.
8 pizzas. Yeah, that were all like this big.
So
Good size
for how
pizza.
many people though?
For 4 people.
Great.
And we ate them all.
Great.
And then there was dessert. There was a ricotta cake for dessert.
And you're like, I'm gonna go get my cholesterol levels checked. Yeah. I'm gonna go weigh
and so
in.
I'm like rolling into the nurses. I'm like, oh, how's my cholesterol?
Sir.
Give me a second here.
Sir.
Scales over there, huh? Gotta roll my chair onto it.
Oh man.
But my numbers came out fine. No,
Good.
but it is a struggle. Like my wife bakes all this, so like every night she's baking because it's out of our house. It's an online bakery for catering and everything.
Oh, awesome.
So she's constant. There's like she's always experimenting. There's always leftovers. There's always extras. It's just
that's amazing. Yeah, everybody's like Pog.
Cooter Brown. We used 5 pounds of flour.
Wow.
There was 5 pounds of flour consumed in pizza form.
My goodness.
And he's really good. So his name is Manu. He's been perfecting the at-home pizza making technique, like the best you can possibly be without having an 800-degree oven.
And that's how they got me too. Leftovers. Yeah, leftovers are great. Between 15 and 25, I always ate 2 pizzas. Jesus. So here we'll get into the space stuff because I know people were asking questions. But that's amazing, and the
science stuff.
The trip is science stuff. It's amazing, and also the fact that you could eat that much is also science. That's also amazing.
Lots of amazing. This is science, true science facts of the world.
Right. And so someone asked about time dilation. I saw a few people talking about this in another chat as well recently.
Actually, I saw you guys were talking about brown dwarfs before I came in. I just released a podcast about brown dwarfs.
So we watched your, let's see, it was the brown
my videos.
Yeah, we were watching The Hunter's Guide to Brown Dwarf Stars, and I was going to click on the next one after that because you got me with this brown dwarf star. You hooked me. Are just plain weird.
They are.
Yeah. But time dilation. Do you want to?
Time dilation is also weird. Let's talk about time dilation.
Okay. So let's talk about it. I forgot what
is that the entirety of my prompt?
The question was way up. I don't. If someone's in here that asked that, I forgot who asked it. Someone asked it, and I don't know what they said. Talk about it. Yeah.
Talk about it.
Oh wait. Here. So while someone's remembering to answer or re-ask that question, words. DPI says, what happens more in brown dwarfs, deuterium fusion or lithium burning?
I'm guessing deuterium here. Deuterium is way more common than lithium. Basically, nobody cares about lithium. That is the most important lesson you need to know from all of astronomy is that lithium is dumb. It is the worst element. I don't even understand why we bother having it. It's just lazy. It's just a grifter. A good for nothing. Lithium doesn't matter. Sorry, I have strong feelings about lithium.
Yeah, apparently. I didn't expect that response at all.
It just came out.
Yeah.
Started as a joke, actually, between me and John Michael Gaudier, and it spiraled from there.
Someone goes, it's good for bipolar. They actually do use it to treat that.
Yeah, okay, there is all that medicinal stuff, but astrophysically.
Right.
Dumb, lame, worthless element. I'd rather have boron 10 times over than lithium.
Deuterium ion batteries for the win. I cannot even read.
Instead of lithium ion.
Right.
We'll have deuterion.
Deuterion. I had to put on the glasses. Okay, so Jonathan, you asked, okay. What is time dilation and how do we know it's real?
That's cool. So like I always say, I love questions that ask, how do we know this? Because you shouldn't take anything I say for granted. You should. I'm not a preacher. I'm not asserting this is true. I'm saying things are true or accurate based on the weight of the evidence. And so time dilation is moving clocks run slow. moving clocks run slow. Moving everything runs slow. The faster you move in space, the slower you move in time. How can we tell this? We can literally measure it. We can take an atomic clock, which is kind of accurate, put one on the ground, put another one next to it, synchronize them at the exact same time. Take one of them, put them in an airplane, and fly that airplane around the world at a few hundred miles per hour, land it, bring it back and check, and the clocks are different. And the clocks are different in the exact amount that we predict from special relativity. The clocks are different because one was moving fast in space, which made it move slow in time. It lagged behind the other clock. We can measure this. This is a real thing in our universe.
So also, so that what you were saying is just like keeping it more earthly bound with what we have with the GPS system.
Yeah, exactly. So this is another place where we know that time dilation comes in. We have satellites in space that are doing this whole precise GPS thing. They are buzzing around the Earth at tens of thousands of miles per hour. They're moving really, really fast in space. They are not moving as fast through time. The clocks on those satellites are different than a clock here on the ground. And that difference must be taken into account in order to get GPS right. If we didn't know anything about time dilation, your GPS would be wrong.
So can you work this into how, because a lot of people ask me about this, it was my favorite part of Interstellar was how they showed this, how they represented time dilation with the guy being up in the spaceship.
Yeah.
And then Matthew McConaughey being down on the planet.
20 years.
Yeah, it was like 1 hour was 7 years.
Something like, yeah. So moving clocks run slow. Accelerating clocks run slow because acceleration makes you go faster. Acceleration can come from a rocket, from you running really fast. Acceleration can also come from gravity.
Because
gravity causes acceleration.
Would you say that gravity is acceleration?
I might just say. That gravity is acceleration. And acceleration is gravity.
Ooh.
Saucy.
Yeah, that's mind-blowing.
Flipping the script.
Yeah. So does this mean that the guy in this spaceship, and I'm of course I'm asking redundant questions just in case anybody...
And of course it's a man.
Right. You would have me on that spaceship. I'd come back and be like, spent 21 years. Is the longest 3 hours of my life.
You have to say it as an old lady now.
Oh, yeah. Well, I wouldn't be an old lady. I'd still, I'd still have some pep to my step, So I wouldn't be... I might be angry.
20 years
I might be a little angry.
He seemed remarkably chill about the whole thing.
He was so calm about it. He was like, yeah, no big deal. No big deal.
I've just been alone for 2 decades.
Right. I mean,
twiddling my thumbs.
Yeah. We're out of food. We've been out of food for at least the last 5. Yeah. So he was moving.
So the guy on the spaceship. So the guy on the spaceship. So let me go back to a satellite because there's 2 things happening to a satellite. One is that it's going really, really fast in orbit, so its clock will run slow. But it's also far away from the Earth. So that makes its clock run a little bit fast. So there's actually 2 competing effects on a satellite. Turns out the going really fast one wins in this particular case. For the interstellar case where they're had that planet near the supermassive black hole, the people closer to the black hole that were sitting on that planet, in the wavy planet, they were experiencing incredibly strong gravity. They were experiencing a lot of acceleration. Their clocks were running slower. So 1 second for them was hours or months or whatever for everybody else in the...
Right. So the closer you are to the center of gravity, right? So like if we went down, let's say you were super nice to me and you're like, Sky, I'm going to send you down to the center of the Earth. I know. So I already kind of made that a...
I reject
I made it a reach right out the bat. Okay, well, so let's say you send me down to the center of the earth and it gets a little warm
Okay.
for me, but I'm totally fine. I can human it for some weird reason. I'm fine. I can deal with the
Because you're
pressure.
a devil.
Right. Yeah. I can somehow manage.
Beelzebub incarnate.
Right. I'm good. I'm fine. So I go down to the center of the earth. It's really, really hot. There's a lot of pressure, tons of pressure. Time's going to move slower for me than it would for you.
Or would it?
Well, I'm closer to the center of gravity, right? Maybe.
Inside. Maybe. I'm giving you old professor trick
Go ahead.
of asking you questions to make you doubt your assertiveness.
And then I just had an airplane fly right over, which added to the intensity of that moment.
Ooh,
And I got a little
that
distracted.
was my point. That plane was carrying my point.
And it went right over my head.
Straight out, miles above.
So,
In the center of the earth, you would feel weightless.
why is that?
Think about if you're at the center and the earth is a perfect sphere. So there's some rocks over here that are pulling you in that direction.
Oh, right.
But then there are rocks over here that are pulling you in that direction. Perfectly balanced. Rocks over here pulling you up there, but rocks down here pulling you down there, perfectly balanced. You end at the exact center, you end up being totally weightless.
Okay, so let's say I'm not right in the middle then. Let's just put me a little bit north of the middle.
Whoop.
I'm just going to take the elevator to floor 2.
Yes. The iron dynamo level.
Which everybody wants to go to.
Second floor, lower magma.
Right, that's where you'd find me. So in that case...
I have no idea. I forget what you're not. I'm gonna be a little bold here because I think I'm remembering something.
Okay.
Anywhere inside the earth, you'd be weightless. At some level, once you get deep enough. Because there's, let's say you're closer to the surface over here. So there's less stuff over here. There's way more stuff over here. Right? But this stuff is closer to you.
Right.
So it has a stronger gravitational pull.
Right.
And that stuff, even though it's more of it, it's generally farther away from you.
But there's more of it.
But there's more of it, but it's farther away.
Right.
I think it balances.
It would balance, I would think. Maybe.
I don't know if this is true.
I'm totally fine having this thought
someone's
experiment.
pulling up the Wikipedia article right now. If the Earth was hollow, like a shell, you could be anywhere inside it and you'd be totally weightless. If it's filled, then maybe there is gravitational differences.
Someone said,
yes, I'm basically making stuff up
we're
right
just,
now
yeah, we're
based
just
on things I half remember.
Right. If you're in the center of Earth, you don't feel gravity, but is the effect of gravity still slowing down time?
Yes. Oh, I had a knock on my door.
Okay, no problem.
A visitor.
Oh no. In before student.
She just walked out.
Just a normal day in
Undergrad. Go away. Get off my lawn.
hourly cheese delivery. But okay, so on the planet.
I'm sorry, what?
So when we get back to this,
I want to talk about the hourly cheese delivery.
I know. Well, that's what they just thought it was.
Can we partner with like Astro Tours? Can we make this happen?
This would be amazing. So going back to the whole interstellar thing.
Okay. We got sidetracked.
Right. So obviously the people on the planet, time is moving slower. And the people or the dude that's getting really upset because it's been over 2 decades on the ship, time is moving faster for him. Now,
time is moving like normal for him.
Right. But wouldn't it be experienced? This is where people get really hung up on this because this is the part that gets really tricky, even though it's a simple statement. Matthew McConaughey on the planet didn't realize that time was moving faster for him because it was just time for him. The only way that you would know time is moving faster, and correct me if I'm wrong, is by having another point of view to reference.
Yep. If you're on this planet with strong gravity, you would feel the strong gravity, but that's something else. you don't feel like you're in slow-mo.
Right.
It's not like you're like, oh, get to the ship. You just feel normal
Right.
because everything is slowed down. Your biological processes are slowed down. Your chemical reactions are slowed down. The motion of those waves are slowed down. Everything is slowed down. But if he were to pull out a telescope, and this is his telescope,
Oh,
and he would look at the dude in the spaceship,
yeah.
the dude in the spaceship would look like he's going super fast. Like,
Yeah.
and same for the dude in the spaceship. He feels normal.
Right.
He feels normal. And if he gets in, he gets out his telescope. He's looking down now.
Mm-hmm. Very
He looks
condescending.
down, like, or just like rolling his eyes. What is taking you so long? You are moving like just slugs. Because that's what it would look like to him. Like Matthew McConaughey would be running. To Matthew McConaughey, he's running normal,
Uh-huh.
with
Yeah.
his like abs flexing and everything.
Right.
But to the dude in the spaceship, which nobody remembers his name,
Yeah.
by the way.
No.
No one knows.
Nope.
No one knows. And but to him, looking down, Matthew's doing like the whole Baywatch thing, like what you perceive about the world is not consistent with what other observers perceive. Nobody agrees on anything.
So go on.
I was going to say special relativity gives us like the translation between different points of view. It tells us how to translate what the dude in the spaceship is seeing versus what Matthew McConaughey is seeing. It gives us the mathematics we need to go back and forth between those two frames of reference. But without that mathematics, without that, it's all nonsense.
Yeah, and so with that, so I had this conversation with somebody last night because I was trying to explain that. I was trying to get into this, and they were like, "Well, what if you could send me into a place in space where I'm not moving and I'm stationary?"
Okay.
Yeah.
Okay.
And he's like, "And I'm not affected by anything gravitationally," and I'm like,
Zero gravity.
Good luck if you're not being pulled by anything, because you also have dark matter, right?
We'll put you out in the middle of a intergalactic void.
Okay.
Where the nearest thing will be like, besides like a speck of hydrogen, is like 1,000,000 light years away.
Okay. So what would happen then?
Well, you would die because you're alone.
Right. So I gave him those things, and then that's when he just cut me off and said, "I'm depressing to talk to." So I was like, okay, well.
I mean, that's true. He's not wrong.
I know. Well, how do you talk about space being like, well, that would kill you?
Well, we're alive because of space.
Right.
But it's also trying to kill us.
So let's say you put me out into this, or you put that guy out into the void. He's not moving. He's completely stationary. Nothing is pulling him or pushing him. No forces are acting upon him.
Correct.
So
then he gets, if he's really not moving, then he gets no time dilation whatsoever.
That's what I told him. He wasn't satisfied with that.
And
because I said he could be looking at the Milky Way but not moving. Right? So you have another point of reference. Because that's what somebody just said. So stationary relative to what? Say that he's looking at the Milky Way.
Well, that's another thing, which is motion. This is the relativity and special relativity. Motion only makes sense relative to something else. You can only tell that you're moving by comparing yourself to another object.
Right. So he's not moving, but he can see something else. So he was wondering what happens with that observation. And I said, well, time dilation wouldn't exist then in that case.
Yeah, he wouldn't get any time dilation.
So +1 to me, maybe.
+5.
Okay,
+5.
Nice.
We'll go. Congratulations, A-.
Okay. Well, he still walked away and said I was depressing to talk to because I told him that the chances of him being stationary in space with no forces acting upon him and to get out of the Milky Way, and for that to work, Yeah, -10 for being depressing. Yeah, see. I feel like that's a fair score though. So
I try to be fair in my grading.
yeah, because he was like, well, this is a solution to time travel.
No,
And I said, no,
no.
it's not. He's like, well, what if we had people we could be stationary and then, we can just watch them since they're closer, they're moving through space faster or whatever and closer to gravity, stronger gravity. And I was like,
So you can jump forward in time.
right.
That's totally cool.
Mm-hmm.
You can skip ahead in time by taking advantage of time dilation, but you can't stop and you can't turn around.
Yeah. I had to graph that out for him.
Did you actually have graphing paper?
No. But I had a piece of paper.
One moment, my good sir.
I had.
Let me draw you. This is called a space-time diagram. Now, this represents your world line and your light cone of acceptable possible futures.
Right. No, I didn't have graphing paper, but I did have a piece of paper because he kept trying to make it a situation that
made it a thing.
Yeah. And I just told him, I said, it's not going to work out that way. That's not how that works at all. And he said, so
I guess, yeah.
So why did the planet have why wasn't it torn apart if it was right next to the black hole? And I said, it was, and within a healthy limit of where, tidal forces would actually tear stuff apart.
Right. I think they did it. This was Kip Thorne, the science advisor, Nobel Prize winner last year, who did all this to make sure that it wouldn't be ripped apart, that they have the right time dilation factors and all that.
And they had huge tides on that planet. Do you remember the tides?
Yeah, the big old tidal waves. Now, I don't think those were tidal waves.
You don't?
So tidal waves are big, but they're not big in the open ocean like that.
So you don't think there was any kind of tidal forces from the black hole pulling on that?
So there were tidal forces. But I think they manifested not as tidal waves, but as something called, are you ready for this?
I'm so ready.
Solitons.
Okay.
Solitons.
That sounds really sad. I don't know why.
Because it's solitary. Because it's just one wave pulse. Whoop. One wave pulse. Exact same noise of moving from the center of the Earth. Is also used to describe a wave pulse. A whoop. There's periodic forcing from the gravity of that giant black hole on the water on that planet, but the water is relatively shallow. And if you do this kind of periodic forcing, then you can get all the waves to group together into a single big giant wave or just a few sets, and these are called solitons.
Oh, interesting.
So I think those waves were tidally forced. They weren't necessarily tidal waves. I think they were solitons.
So here's the bigger question about it. Is any of that really feasible? Could we get to a planet that's next to a black hole and orbit the black hole and be fine?
Yeah.
There's a lot of, I know I'm leaving out
we can't really travel to anywhere interesting in the galaxy.
Right.
Let alone the nearest black hole is 10,000 light years away?
3,300.
3,300 light years away. That's exactly what I said. And but if we could go there, we could orbit around it. We could experience time dilation effects. I don't think any planets are going to be stable around supermassive black holes just because there's a lot of complicated astrophysics also happening there that would tend to rip apart or consume any planet. But yeah.
So because I had that question last week, someone said, so can planets be around those stars that are orbiting the supermassive black hole in the middle of our galaxy? Because there is one star that goes around every 17 years and it's traveling at 0.3% the speed of light, SO2.
Yeah, good old S0, SO2.
Yeah. So that one's going, that thing's hauling. 0.3% the speed of light is incredible. So, planets being around a star like that.
I think there could be, but I'm wondering if, because of all the massive gravitational interactions, that any planetary systems will be ripped apart.
Yeah.
There's just too many things happening outside the solar system that can influence the motions of any particular planets. We're relatively isolated here in our solar system. The nearest star is 4 light years away. So nothing's really going to bug us. You
Right.
go down in the core, there's all sorts of interactions between stars, and every time those stars get close to each other, they can destabilize their planet.
And so just to follow up, since we went into this, so if we, and you've heard me ask you this so many times, but I'm doing this just for anybody else that's new in here that doesn't maybe want to
all
ask
the
this.
noobs.
Right.
We
So
still using noobs?
yeah, I think so.
Okay.
Maybe.
Okay.
I think so.
Is there anything that's replaced it?
No, I would say like new people, but that doesn't really new friends.
New people.
New friends.
New friends. A nugget. A pleb.
Plebs, that's
No, the
it.
plebs-
Oh my god, that has
But they're
replaced
not new.
it.
Plebs are just like the hoi polloi, just the unwashed, ignorant masses.
Touche. So when you travel closer to see this, when you go towards the speed of light faster and you approach the speed of light, what happens to you? So if you put me on a ship and you're like,
You die.
Sky, I know. Well, see, and that's when I get the
Oh,
depressing
you want
stuff.
the long answer.
I
You
want
the
that.
long-
Let's say I'm not. I want to say I'm not human. Like, let's say I couldn't die.
Because you're Beelzebub incarnate.
We've been over this like 5 times. Yes.
I know. Well, it comes up. You're the one with these Gedanken experiments.
Well, because these are what people ask me. Like, in when I'm sitting on the couch, like I just want to watch a movie.
And who are these people?
This would be my boyfriend.
Oh, I see.
He's like, no, wait, I have an
So
idea.
your boyfriend is just like, hey, this is your boyfriend's voice. What if you were to go like really close to the speed of light
I was like, yeah, you're gonna be dead. And he's like, well, no,
and
let's say
not-
that doesn't happen.
and not die?
Right. I was like, well, that's going to happen. And he's like, well, you know, I forgot what he said. He said something about, I'm impressed in and of it. Like the fact that he can actually ask me these questions,
Like formulate.
actually
Yeah, like when a
ask me these
4-year-old
questions.
asks
Oh, yeah.
you,
Like these are,
like, what restaurant are you going to? Like, wow.
yeah.
Okay, you're starting to comprehend language.
Yeah. And he was like, well, you know, so he goes, but, you know, how come we haven't found life? Like, you know, why don't, you know, if we send out like x-rays, you know, out to like, you know, things or, you know, not. And I was like, x-rays? And he's like, no, radio communications. And I was like, well, radio would also be energy, which would be light. And he's like, well, it doesn't have, and I'm like, no, it has mass, but for all intents and purposes, you can say a photon doesn't. That's a photon. It has momentum. He's like, well,
This is
it's
the
not
worst
fun anymore.
audiobook I've ever downloaded.
I know. And then I was starting to feel like I was being terrible at describing things. I said, well, you can't be.
Welcome
He's
to
like,
my everyday life. No, I'm not saying your boyfriend's ignorant, but like I run into a lot of interesting characters, both online and in person, where, you know, I don't always succeed, but I work really, really hard to take like a complex astrophysics concept and find a way to share it or some nuance of it, and, you know, to explain it so people understand. And it's one thing if someone says, I didn't get that. Like,
Right.
I don't understand. That I'm like, okay, I failed as a science communicator. I didn't quite reach you. Okay, what can I do to make this understandable to you? But then there's another flavor person that just says, well, I think blah, 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 blah. And I don't know how to respond to that, because the answer is, well, no, you're wrong. And you're wrong because science. But is this just your way of saying I don't understand what you said?
well, yeah. The funny thing was, and you know, he was saying, yeah, you keep telling me how I'm going to die or how that wouldn't work, but I don't think you're understanding what I'm like, maybe I'm not understanding what you're asking, you know? And cause that can happen. Some people ask me questions and I could, you know, just, it's part of understanding the question and then working with it. And sometimes these questions
people ask questions and they don't know what they're really asking.
right.
And I mean, I do that too, where I just say, there's a question inside of me and I want to get it out, and I'm just going to pick the best words at the time, but it's not going to be quite what I was hoping to learn.
Right.
And so as a science communicator or educator, you have to like try to bridge that gap. Like, hey, here's what they actually asked. Here's what they're really asking about. And here's their background. And here's their preconceived notions. And here's their knowledge base. Now try to spin a story. So if you were to try to go close to the speed of light, there's a problem here, which is that if there's any radiation around you at all, and there will be because there's all sorts of radiation out there,
right?
It'll get boosted. It will get shifted to higher and higher energies the faster you go. So you end up getting a face full of X-rays or a face full of gamma rays.
Great.
As you try to go fast, like as you're like swimming against that soup of radiation, the faster you go, it's almost like you have to plow through that radiation and it gets to higher and higher energies. And so, yeah, it sucks.
Yeah. Yeah. He was actually trying to have me send him into a black hole and not die.
And like stay in the black hole.
Well,
then have a long distance relationship or something.
He was like, well, if you got close to it, you know, like you can actually get close to a black hole and not die. And I said, well, yeah, there's going to be you can orbit things like that as long as you have you have to work this out mathematically where this would be forgiving. You couldn't get super close. I'm like, even light can't escape. The escape velocity of light at a certain point.
If the escape velocity exceeds the speed of light, you're not going to get out.
Right.
Now, you can fall through a giant black hole without being destroyed. Maybe. Do you want to? You can pass through the event horizon. And then you'd be inside the black hole.
Right.
And not dead.
Maybe.
And then you'd die a few seconds later.
And what's really sad is no one could witness that. That would be just your story.
Everything else.
That's what
Unless someone was in the black hole with you. If two people fell together, then they would watch each other die.
Wow, how romantic.
Not sure if that's any better.
I don't feel like it is. Just stay on the horizon. And people always ask like what the shape is of a black hole over and over again.
Well, black holes are round, but if they're spinning really fast, they're less round. They're bulgy on the edges. That's it.
That's it.
Black holes are incredibly complex and mysterious, and we don't fully understand, but they're also really, really simple. They're very straightforward objects.
How so?
As in, you can completely describe a black hole with just 3 numbers. With its mass and its charge and how fast it's spinning. Those 3 numbers completely describe a black hole. They're the only inputs you need into the math to 100% characterize it.
Someone goes, what? I don't know what he's wedding though. 10% the speed of 10% the speed of light is quite big. Yeah, 10% the speed of light is intense.
Fast. But still it gives you like a 1% time dilation factor.
Right. Considering how often black holes merge, most of them are probably 2 or more lobed, like peanuts.
Ugly peanuts. Not like a nice symmetrical peanut. 2 lobes. So temporarily, the black holes are ugly when they merge. They're orbiting around each other. They'll kiss, and that kiss will expand, and they will look kind of peanutty shaped. But then their event horizons merge together, and they'll wobble for a bit. They'll shake. This is called the ring down phase, and this is one of the things we can see in the gravitational wave observatories is this ring down phase, and then it settles in, and it'll be back to being round with no lobes.
And when you say round, can you give people an idea of what you mean by round?
Like a sphere.
Okay.
A sphery.
And someone just said or asked.
Round.
I know, but sometimes people are like, well, what does round mean?
Is it round like a football?
Use it. Lisa's out. So Viking says, is a black hole another a way to another galaxy?
Buried in some of the mathematics of general relativity, you can construct things called wormholes, where you fall into a black hole and it's actually a bridge to a white hole. So you get sucked in one side and popped out of the other, wherever that other is. turns out the white hole side, the thing that's constantly blasting out, is totally unstable and evaporates right away as soon as it's formed. There's no way of keeping it stable. So it's just black holes. So as far as we know, you fall into a black hole, and the only thing you're headed towards is your doom.
Right. And with a wormhole, like some of the things that, so you can mathematically work on this, but the amount of energy it would take to keep a wormhole open, to travel through. Right?
Yeah, to keep a, and I did not choose the terminology, but to keep a wormhole throat.
Right. I know. I was going to say it, but I thought I'd let you just go ahead and take that one,
Take that, talk
just
about
take
the
it for
throats.
the team. Yeah.
Yeah, to keep the throat open.
Right.
So it can, vomit spaceships.
Right.
It's not that it requires a lot of energy or a lot of mass. It requires negative mass.
Okay.
And that's not a thing. That doesn't make sense.
You don't have anti-mass?
We have antimatter, but it's still positive mass. There's no such thing. There's nothing in our universe that weighs -5 pounds.
Right.
Yeah. So without negative mass, you can't stabilize a wormhole throat.
Okay. You said it twice.
I said throat a lot of times.
Okay, maybe 3 or 4 times. Got him.
Throat.
So wormhole open is feeding geese. So wait, is that analogous to negative energy?
So negative energy is so negative energy crops up in a couple things. One, there's dark energy, which has negative pressure, which is a whole other discussion. And then you have things like binding energy, which actually I'm going to record a podcast tonight about binding energy.
Interesting.
And that's negative, but that's like more of a bookkeeping thing. Negative mass does not appear to be possible in our universe.
Yeah. I mean, that makes sense.
Sorry, folks.
Yeah, because I'm thinking of the equation to get weight. You wouldn't get a negative weight.
No, and if negative mass existed, you can play mind games of like how would this affect momentum,
right?
Emotion. Like you could have a negative mass and a positive mass sitting next to each other, and you just put them on the table, and they'll just spontaneously accelerate,
right,
as fast as they can possibly go, which breaks all of momentum, conservation of momentum, and inertia. It's just freaky stuff.
Yeah.
Don't play with negative mass.
No negative mass. Time to switch universe. Error brain net found. No, actually, what I'm thinking of is because what you're just saying there. So you can have a large momentum, but that's going to be dependent upon speed and mass. So yeah, I'm just working that in with what you're saying because this is
like
interesting.
It'd be analogous to charges, electric charges. Like a negative mass would be attractive to a positive mass, and a positive mass would be repulsive. Or no, it's the other way around. But I forget how it works out, but they end up like dragging each other along spontaneously, which like just doesn't happen.
But see, that's the thing. So, and then that's one of the things to be wary of, guys. Whenever you are in a Twitch chat and people are talking about science, if they just start throwing anti in front of everything, they're like anti-mass, anti-energy,
Antifa.
Antifa?
Maybe.
The only thing we know of, is like we definitely have the sorry, you already said it. Antimatter with annihilation.
Yep. That's cool. No, I feel bad for the plebs.
I know.
Actually, because I realize that almost everything I'm saying is like full of jargon and assumes already a lot of knowledge and understanding, and it's very, very easy for what I say to just sound like complete nonsense, and it's very, very hard to distinguish what I say from complete and total garbage.
Right. And so what people do, the plebs, what they do with that is they just start talking actual nonsense, and everybody's like, that seems good.
That's valid.
seems good. He just used the word anti-mass.
Anti-mass.
Great. Yeah.
Hope hates that.
I can't. It's just, yeah. Well, the thing is that anti sometimes simply does not exist. Right. No, that's what we were just saying.
Yeah. Not everything gets an anti.
Yeah. You can't just throw anti on there and be like, this is great. So how does NASA or the ESA measure the size of a black hole? Well, you just kind of hinted towards that earlier. How do we actually find that?
Right. So it's very hard to take pictures of black holes themselves because they're black and space is black. But when stuff is falling into a black hole, as it's falling in before it reaches that event horizon, it scrunches down, it compresses, it heats up, it gives off an enormous amount of light, and we can see that light. And from the temperature of that gas, from its size and its shape, we can figure out how big the central object is, both its mass and how wide across it is. And this is how we get estimates on the sizes of black holes. Now, this is going to change hopefully in the next few months, where there's an international collaboration called the Event Horizon Telescope, which is actually a network of many, many telescopes all across the world who have been attempting to directly image the supermassive black hole in the center of the Milky Way galaxy. They took all the data about a year ago. They've been processing it ever since. It's an incredibly tough data analysis problem. So I'm not surprised it's taken a while. But what they're going to see, and when we have simulations of what we expect them to see, is they'll see the gas surrounding that central supermassive black hole, and there'll be a hole in the center of the actual disk of the black hole. Or sorry, sphere of the black hole.
That's what cool. does it. That's what does it. People hear accretion disk, you know.
There you go. I see the emojis.
Yeah. See, people think accretion disk, so therefore they think it's flat.
Right.
I can understand that.
The accretion disk around it, it's a pancake around it. The black hole itself is round.
So it's like Saturn.
Like Saturn.
There we go. That's a good way to think of it.
Love it.
This question did get asked a few times, and I did see him. And sorry, guys, if we haven't answered everything, but the conversation's flowing quite nicely, and hopefully we're answering some of the questions you guys had.
This is organic.
This is very organic. So I think that this is a frequently asked question, but how do you pursue a career in theoretical physics?
You don't. Actually, I wrote about a year ago, I wrote 2 articles back to back. Actually, I did 2 podcasts about. One was here are the benefits to studying astronomy and physics and the good things you can do in life. And the other was how there are no jobs in physics and astronomy. And the reality is that we are graduating, we being physics and astronomy, we're graduating about 10 new PhDs for every 1 open research position. So 90% of PhDs in physics and astronomy do not do physics and astronomy long term.
They just become accountants.
They become stupid rich doing data analysis, doing consulting, doing finance. Like, they make so much money.
Yeah.
The least well-paid thing a PhD in physics and astronomy can do is physics or astronomy. Becoming a professor, becoming a lab researcher. And so I try to be upfront with that with people, especially, high schoolers. Say, I'm really inspired by you, Paul. I'd like to do what you do. That's the first thing I tell them. I try to crush their hopes and dreams early.
Right.
Which I think is more fair than crushing their hopes and dreams later.
Oh, yeah.
It's still fruitful. If you want to get a bachelor's, if you want to get a PhD, that's all really fun and cool. You can still do research. You can do a postdoc, engage in research for 2 to 5 years before going off into industry or doing something else. So you can still contribute to science in the scientific enterprise, even knowing that's not going to be a long-term thing for you.
Maybe I'm wrong, but I think the big paycheck might be in applied physics.
Applied physics, taking physics, working with engineering firms, yeah, big bucks.
Yeah.
We're talking minimum 120K a year jobs.
Someone just sent a link saying that team creates negative mass lab.
That is fake news.
It's from Universe Today.
I know. Who wrote this? Matt Williams. Okay. It's no, I don't blame Matt Williams. I don't blame Universe Today. I blame
Fraser.
I blame the research. Fraser Kane.
Fraser.
Fraser. And I can't decide if it's Fraser or Fraser, and I feel like you say it different every time.
It's Fraser.
Fraser.
It's not Fraser. Fraser would have a Z-I-E-R, but he's
right.
Yeah.
But every once in a while, I swear I hear Fraser.
Not from me. I'm very good about
that.
From
him.
I correct other. From him. Okay.
Yeah, he's like, "Hey everyone, I'm Fraser Kane." I'm like, "Wait a minute.
Wait a second. What are you doing?
Where am I?" Fraser Kane. I don't blame Fraser Kane. I actually blame the researchers and the university press officer for that one. They deliberately chose wording in their paper and in the press release that was technically true for the jargon in their field, but they knew what it actually represented to the general public, and they decided to go down that direction anyway.
Mm-hmm.
So I actually frequently take to task my fellow scientists because they're humans.
Mm-hmm.
They like attention, they like love and respect and all that. It's fun to do interviews, it's fun to be in the news, and some scientists will actively distort their findings or present them in a inaccurate way to get attention.
That is such a weird phenomenon. I've never seen that anywhere.
Yeah, I know. It's very isolated just to scientific circles.
Yeah.
Really.
Wow.
Really, these attention seekers, you're only ever going to see that in the halls of academia.
Yeah, I agree.
Yeah.
It's completely foreign to me outside of that. But, I mean, now that's a perfect example of it, guys. Now you have one.
Yeah. Now you understand that, intellectually you can look out for it. It's there if you look hard enough.
Yeah. So that wasn't a thing? A lab didn't discover negative mass?
So they were playing around with some ions in a box, and they got the ions to move backwards.
Like you do. Mm-hmm.
Despite, so like the radiation was pushing stuff forwards, and the ions moved backwards because of some very complicated quantum mechanical effects. And in the jargon of the field, that's called like negative momentum, negative mass, because they're moving in the opposite direction. But it's just a jargon term in the field. It's not what we mean when we say negative mass as a negative mass. And they knew it.
Oh, man. That's very interesting.
People will lie.
Yeah. Yeah, it's not really negative mass.
I don't get it.
Yeah.
Not really.
So.
Not the capital N, capital M negative mass.
Right. Do you want to maybe take one more question and then?
Let's do it.
Okay. Next question. Something short because we only have 1 minute, less than 1 minute, but thank you, of course. It's good to see you again. We're just waiting.
Good to be seen. How have you been the past few weeks?
I've been good. I've been really busy, but I've been good.
Yeah, Joe said you've been busy.
Yeah.
Good busy, bad busy, medium busy.
So we have TwitchCon next week, and so I'll be on the NASA panel. Right, and they're calling me the crude Carl Sagan, by the way.
I love it.
Yeah, thank you for that. You coined that one.
I did?
You did.
I did.
You did on your radio show. You did it. You just
to introduce you.
You did. You were like, so she's kind of the crude Carl Sagan, and I was like, oh man, this is amazing. I mean, this is it. True though.
That's my moment.
So now NASA knows me as the crude Carl Sagan.
That's amazing. But hey,
you
got invited to the NASA panel at TwitchCon, and I didn't. So Maybe it's good to be the crude Carl Sagan.
It is. It is. And Joe refers to me with that terminology as well. That's great, Joe. Oh, wait, here we go. Has the EM drive... Oh, man. Okay, so has the EM drive been disproven?
The EM drive never existed.
Okay. Is the weird thrust they've measured sorted out now? That was the second part. That was a twofer.
They never measured anything. It was just noise. It was just fluctuation, wishful thinking. The data never supported it.
So, Dr. Paul, do you have a book? Do you have a book? Did you write a book, Dr. Paul? Your Place in the Universe? Wow.
Your Place in the Universe, just for you.
Available for pre-order?
Each one personalized like a horoscope. Except they're all the same. You're going to die lonely and afraid. It's available for pre-order on Amazon. I promise it's a good book. The reviews are hilarious.
Mm-hmm.
And very divisive. Very
awesome.
Divisive.
Well, thank you for hanging out, guys. This is Dr. Paul. All of the information will be linked here in the description.
Yes.
We're going to be looking at some of his YouTube stuff. If you book an Astro
Tour, I will pay money to Skylias.
I will make money off of you guys going and looking at stars and potentially ziplining or doing other fun things while looking at stars with other people that love stars.
Can I get that copy for social media posts? Thank you. That'll be at the top of the website.
Oh, please do. What if you book? I'll tell you guys about it. I'm going to let him get back to it, guys. But thank you so much, Dr. Paul. And I will see you maybe next week if you're around.
Next week is something special. So I will be around next week. But next week, the Siren Modern Dance Company is coming to New York or to Columbus for a residency. And so I'm going to be with them all week because we're working on a project together. And I'm going to live stream from our practice studio.
Oh.
So I'll be talking, but there'll be dancers behind me doing dancer stuff.
That's amazing. We'll see how much science we can get done. We'll science how much science can be done. Everybody's going to be laughing.
We'll talk about time because the point of so I love working with artists and especially dancers to explore scientific concepts and translate scientific concepts for new audiences. And the project I'm doing, we're exploring the nature of time.
Oh, and maybe spin too. I'm sure that's an easy one.
Just time.
Okay. All right. We'll tackle time tomorrow with dancers.
It's not
tomorrow.
Joke.
Next week. Wow.
Next week.
Okay.
One day at a time. Come on. Focus.
I know. It's crazy. It's chaotic. All right. I'll see you soon.
Take it easy. Thank you. And thank you, everyone.